You know, when you gear up for a dive, it's easy to forget what you're actually doing. You're not just strapping on some equipment, you're strapping on a complete, self-contained underwater life support system. Seriously, everything from that tank on your back to the regulator in your mouth is designed with one single purpose: to let you explore a world where we just can't survive on our own. So how does it all work? Well, let's follow a single breath on its incredible journey. Seems like a pretty basic question, doesn't it? How do you breathe underwater? But the answer? Man, it involves this amazing journey. We're going to follow one little puff of air as it travels from a super high pressure tank through some incredible pieces of engineering, and then finally into your lungs. You ready for this? All right, here's our game plan. First up, we're going to look at the heart of the whole system, the tank. Then we'll see how all that high pressure air is magically made breathable. After that, we'll check out the instruments that keep you in the loop. And finally, we'll touch on the special rules for diving with something called nitrox. Let's dive in. Okay, so everything, and I mean everything, starts with the scuba cylinder. This thing is way more than just a metal can. It's a precisely engineered pressure vessel. And the cool part is, it has its own story stamped right onto the neck. Understanding that story is really the first big step to being a safe, confident diver. Okay, take a look at this. Every single tank has its life story stamped right here. See these markings? That dot, or CTC, is the government giving its stamp of approval. This part, 3A or 3AL, tells you if it's made of steel or aluminum. Right here, that's the maximum working pressure. You don't want to go over that. And this string of dates, that's its safety inspection history, like a medical chart for the tank. So the big debate, steel or aluminum. And you think it's just about which one's heavier, right? But nope, it actually changes your whole dive. Steel tanks, they sink. They stay negatively buoyant the whole time. But aluminum tanks, which are way more common, do this weird thing. As you breathe the air out and they get lighter, they can actually start to float. It means you might need an extra pound of weight or two just to stay down at the end of your dive. Now, here's a fact that might actually surprise you. We put a lot of emphasis on the big, high-pressure test tanks have to go through. But the truth is, it's the simple annual visual inspection that catches most of the real-world problems. You know, things like hidden rust, tiny cracks, or corrosion on the inside. It just goes to show you, sometimes a trained human eye is the best safety tool we've got. So, it really all boils down to this two-part safety check. Every single year, a visual inspection, where someone looks inside and out. And then every 5 years, it's time for the big one, the hydrostatic test. They literally fill it with water and pressurize it way beyond its normal limit to make sure the metal is still strong. These aren't just suggestions, they are your lifeline. Okay, so we have our tank. It's full of air that's been squeezed in there at over 200 bar of pressure. You absolutely cannot breathe that. I mean, that would be messy. So this next part of the journey is all about the magic of taming that incredible pressure and turning it into something you can actually breathe. The very first safety feature in line is this tiny, unassuming piece of copper called the burst disc. Its job is simple. If a tank is ever accidentally overfilled with too much pressure, this little disc is designed to break first. It ruptures, vents all that extra air safely, and prevents the tank itself from failing in a much more explosive way. It's a simple but absolutely vital piece of the puzzle. Now we meet the real brains of the operation, the first stage regulator. This thing is a mechanical genius. It screws right onto your tank, and it does one incredibly crucial job. It takes that insane 200+ bar of pressure and knocks it way, way down to what we call an intermediate pressure. It gets the air ready for the final step. And that final step happens right here, in the second stage. This is the part that actually goes in your mouth. So on the left, you can see it's just sitting there, totally closed. But the second you start to inhale, you create this tiny bit of suction. That pulls the diaphragm in, which pushes a little lever, which opens a valve, and boom, you get air, exactly when you ask for it. It's just a beautiful, simple, and incredibly reliable system. Have you ever wondered why some regulators feel just effortless, while others feel like you're trying to suck a thick milkshake through a straw? Well, it usually comes down to this: balanced versus unbalanced. The older, unbalanced kind gets noticeably harder to breathe from as your tank pressure drops or you go deeper. But a modern, balanced regulator? It feels exactly the same on your first breath at the surface as it does on your last breath at depth. It's a huge difference. But wait, what happens if it breaks? That's a scary thought, right? Well, this is where the pure genius of fail-safe design comes in. Your regulator is engineered so that if something goes wrong, it will always fail open. It'll start gushing air, we call it a free flow. And yeah, it's going to get your attention. But the key thing is, it will never just stop giving you air. It's designed to give you too much air in an emergency, never too little. So you're breathing easy, you're cruising along. Awesome. But how much air do you have left? How deep are you anyway? That's the whole job of your instrument panel, your underwater dashboard. It's your connection to the critical information you need. All right, the most critical piece of info comes from your submersible pressure gauge, or SPG. Put simply, it's your fuel gauge. A special high-pressure hose connects it directly to the first stage, so it's giving you a live, real-time reading of exactly how much air you have left. You never, ever, ever get in the water without one. Next up is your depth gauge. Whether it's an old-school mechanical dial or a fancy digital screen on a dive computer, it's all doing the same thing. It's measuring the pressure of the water around you and telling you how deep you are. This is absolutely essential for managing your dive plan and making sure you do your safety stops correctly. And finally, we have the good old-fashioned compass. Trust me, underwater, where there aren't any street signs and the visibility can be bad, it is shockingly easy to get turned around. This is your ticket home. You just point that main lubber line in the direction you want to go, turn the outer ring, the bezel, to trap the north needle, and then you just keep that needle in its little cage. As long as you do that, you're heading in the right direction. Okay, pop quiz. Let's put some of this together. Your depth gauge is reading 18 meters. You know you've got the pressure of all the air in the atmosphere pushing down on the surface. So what's the total pressure, the absolute pressure that your body is feeling right now? And the answer is 2.8 atmospheres. Here's why. You always start with one full atmosphere of pressure just from the air at sea level. Then, in salt water, you add another full atmosphere for every 10 meters you descend. So, at 18 meters deep, you've got 1.8 atmospheres from the water, plus the one you started with at the surface. That gives you 2.8. Understanding this is the foundation of all safe dive planning. All right, for our last section, we're going to tackle a special topic, diving with enriched air nitrox. That's basically any breathing gas that has more than the normal 21% oxygen. It has some cool benefits, like letting you stay down longer, but it also comes with some very, very strict rules for your gear. Rule number 1 is that you have to be able to tell what you're breathing at a glance. You will always see this very distinct green and yellow band on any tank that's filled with enriched air. It's a universal signal that says, hey, the gas in here is not regular air. This number, 40%, is incredibly important. It's called the 40% rule. Here's the deal. Pure oxygen itself doesn't burn, but it makes other things burn really, really easily. So any piece of your gear, the tank, the valve, your regulator, that's going to come into contact with a gas that's more than 40% oxygen has to be specially cleaned and use oxygen-compatible materials to completely eliminate any risk of fire. When you dive with nitrox, the ultimate, final responsibility is yours, no one else's. You must, personally, use an analyzer to check the exact oxygen percentage in your tank before every single dive. You check the sticker, you sign the logbook, and you never, ever, ever dive with a tank that you haven't analyzed yourself. Period. So, we've done it. We've followed a single breath from the tank all the way to your lungs. We've seen how every single part, from a tiny copper disc to a complex regulator, works together in a system that is designed for one thing, your survival. This isn't just a pile of gear, it's your lifeline. So I'll leave you with this question. Now that you understand what's happening on the inside, how is that going to change the way you care for it, inspect it, and trust it on your next dive?